Hi all! Suppose an English speaker is taking driving lessons from an English instructor. Can explanations in English help anyway? Our work is based on the intuition that this is possible. In fact, with sufficient repetition, she can associate distant sounds to categories of experience episodes.
Hi, my name is Alex Raymond.
And I'm Francesco Sovrano.
In our paper, we'll talk about how you shouldn't fire a driving instructor, especially if you are a reinforcement learning agent.
Humans use rules to organize and restrict the behavior space of agents. For example, you need to drive on the car side of the road, you can't jump a red light, and so on. In contrast, reinforcement learning agents, by default, don't use rules. They are goal-oriented and they learn how to behave by trial and error, by receiving rewards and punishments and associating examples to those. But why are reinforcement learning agents not using rules? In rule-dense environments, the space of possible policies is large and complex because of the many rules that agents need to comply with. Furthermore, exceptions can add discontinuities to the policy space and make it hard for reinforcement learning agents to explore and find a good policy.
Since RL agents learn from examples, we propose a framework to convert rule-based explanations, telling the agents which rules apply, into clusters of examples. To do so, we use the heuristics of abstraction, relevance, and simplicity. For abstraction, we rely on an explainer function that receives a state transition and outputs the explanations that are relevant to that sequence of states. For example, the agent exceeded the speed limit, or you jumped a red light. These are also known as why explanations. Or if the agent has performed better or worse than average, known as how explanations. We can also combine the different types of explanations together to form a how plus why explanation. After labeling the state transitions, we create clusters to organize experience on a per explanation basis. So the relevance heuristic is about intra-cluster prioritization, as it uses prioritized experience replay to order the state transitions within a cluster by their TD error, while simplicity is for inter-cluster prioritization, suggesting a mechanism for sampling clusters, aggregating the priorities of the state transitions. To do so, we use a new hyperparameter that allows us to adjust the size of some clusters relative to others and allow for oversampling batches likely related to underrepresented cases.
To test our method, we designed 3 categories of environments from scratch, where an agent has to learn how to navigate while following the rules. These are a discrete, grid-like environment and 2 variations of a continuous environment, one with frequent rewards and another with sparse rewards. We instantiate each of the 3 environments with 3 different levels of rule density, easy, medium, and hard. The hardest level has up to 20 distinct explanations, whereas the easiest has 5.
We modified 3 important algorithms from literature by integrating our explanation-aware mechanism, DQN, TD3, and SAC. We use DQN for the discrete environment and the other 2 for both the continuous tasks. And we can see the results here on this table. With the exception of the easiest case in a discrete environment, our method proves a substantial improvement in the performance of those algorithms simply by organizing the replay space in an explanation-aware way.
To summarize, we introduced an explanation-aware mechanism for organizing experience and showed how this can improve the performance of a reinforcement learning agent in rule-dense environments. This can be a particularly powerful tool as we think of explanation engineering as an alternative to trying to cover a rule-dense space with excessively complex reward engineering, even if those explanations are not processed by the agent. We hope this inspires the community beyond, and we urge you to book your driving lessons soon enough. Thank you.
Thank you.